Welcome to the RHCL bridge validation. We have successfully validated core features on this PoC. However, full Avi GSLB equivalence is not yet proven. Let's review the summary. This diagram shows the validated bridge and explicit gaps. However, full Avi GSLB still needs extra design. It is not a direct replacement. This test topology features 3 clusters across 2 domains. The parent DNS delegates to core DNS VIPs on each island. Gateways handle traffic for GLBA and GLBB hostnames. Independent gateway VIPs per domain. Notice that GLBA and GLBB are independent. They carry their own policy and failover. This allows for a truly independent hostname policy. At the base, we have the clusters. MetalLB provides the fixed VIPs. Gateway handles routing, DNS, and health probes. On the left, we stable group per cluster. DNS policies establish the intent. They create DNS records. And they also configure health probes. This drives the core DNS answer. On the letter write path, which handles local configurations. On the right, the read path acts as remote cluster states. Be careful not to confuse these 2 secrets. They have very different responsibilities. 2 secret types should not be mixed. Local configuration is separate from peer cluster access. They have different jobs and different risks. First, the hostname is defined. It attaches policies to create DNS records. Finally, core DNS returns the VIP. That completes the data path. DNS policy translates intent. It creates DNS records and health probes. These drive the core DNS answer behavior, ensuring a healthy gateway VIP. Failover is a continuous reconciliation loop. Trigger pool membership. The controller detects failures and patches the active groups. Convergence depends on your specific system logic. Health checks detect an unhealthy group. The failed group is removed from the active set. The active group's TXT record is updated. Core DNS converges, removing the bad VIP. We start by watching the desired state. Then, we check real DNS answers. Now, let's simulate a cluster failure. See how fast the system converges. Finally, everything returns to health. Repeated DNS sampling proves what clients would actually receive. This provides real data plane evidence, leaving no room for fake evidence. Scenario 1 evaluates same bucket weighting. These 3 clusters are in GONA, with different weights per hostname. This proves weights influence distribution within the bucket. As you can see, the exact same bucket can carry different weights. Here, we have weights of 20, 30, and 50 for our hostnames. This validates our same bucket weighting. Let's look at Scenario 1, where Demo 03 is removed. First, the app scales down, causing the health probe to fail. Now, DNS answers only is validated, and the failed VIP is gone. In this scenario, we look at the details when Demo 3 is removed. The failed IP disappears from both of the pools. We remove it from GLBA and GLB, leaving only the healthy pools remaining. This scenario features 2 distinct regions and 3 clusters. Region A has 2 clusters, while Region B has only 1. We use geo-layered DNS to distribute the traffic. Geo-layered DNS is not a flat global pool. Region buckets change how weight should be interpreted. Do not read cross-bucket weights as one flat pool. Welcome to Scenario 2 failure behavior. Notice that Region A member failures were survivable. This is also true for Region B member down. But Avi-style site federation is not implemented. Survival is validated, but federation is not. Surviving clusters do not prove site federation. The global control plane takeover is still not proven. Weight is not a hard failover switch. It only expresses a soft preference. For hard failover, use active groups remove. Production needs explicit pool membership control. Active groups is the hard switch. While weight controls preference, membership controls eligibility. Production failover needs explicit membership control. Several capabilities are now validated. Some require production design, while others are not proven. It's a capability replacement. During this proof of concept, certain Avi capabilities were not proven. The routing features on the left require a full production design. Site federation and failover measurement are still unproven. First, start with the gateway and clusters. Second, add the production controller. Third, measure intervals and SLAs. Fourth, extend geo and latency. Finally, decide on the Avi migration. Extend only when the customer requires it. Start with failover and add your controller. Then add optional layers like geo or latency.